evolving. The assessment of educational content is a procedure typically carried out by experts in the field of education. In higher education institutions, these experts usually include faculty members, curriculum development groups, and pedagogical teams of faculty-level scientific and methodological commissions. They also include scientific and technical council of institutes and universities, academic councils of faculties, institutes and universities in expert environment where the evaluation of educational content is collegial, discussed and conducted. There is a need to analyze the possibilities of expert assessment of educational content and to develop a recommendation system for assessing educational content. This recommendation system implements the appropriate assessment methodology and a sequence of steps to be taken professionally, promptly and competently. The purpose of the research is to analyze expert assessment of educational content, develop and test models, methods and components of information technology for building a recommendation system for assessing educational content. At Lesia Ukrainka Volyn National University, IT specialists are trained under the Computer Science and Information Technologies educational program. The bachelor's degree curriculum includes 6 educational components in general training cycle, 30 educational components in the professional training cycle, and 12 ones in the elective cycle. The professional training cycle of educational seekers was analyzed for the necessary types of educational content. For the proper preparation of IT specialists within the computer science and information technologies educational program at the bachelor's degree level, the following types of educational content were identified. And you can see all of them to the right. They are noted by K1 till K10. According to the curriculum of computer science specialty, a different number of units of educational content needs to be evaluated for each educational component. This takes into account the specific of educational components and numbers of hours allocated for study. And you can see it in this table. The mechanism of recommending educational publications for printing and use in the educational process involves consideration at the department level during the meeting of the Faculty Scientific and Methodological Commission. It also involves consideration at the meeting of the University Scientific and Methodological Council. The University Scientific and Methodological Council reviews and recommends or reject materials submitted by outsource to the educational department for printing. The process of recommending educational publications have to undergo evaluation by 3 expert committees with the number of individuals specified in the given table. In total, over the entire study period, FE evaluations are required and the following formula is used. Tables provide the quantitative characteristics of expert evaluation of educational content for IT specialist training for each year, and figures illustrate the quantitative expert evaluation. And here you can see the number of expert assessments conducted for the first year, similarly for second year, third year, and fourth year. For evaluating the educational content for each the given years, the different number of expert procedures are required, and the total number for the entire training period is 46,200 284. Overall, it can be argued that the process of evaluating educational content is quite labor-intensive and time-consuming. In the majority of situations, the process of evaluating electronic educational resources and educational content are usually carried out improperly or not conducted at all. The developed and proposed information technology toolkit is aimed at significantly improving, simplifying and expediting the implementation of expert evaluation process for electronic educational resources and educational content in expert educational environment. The goal is to develop a recommendation system for evaluating educational content. Here, the figure shows the functional requirements of information technology components used in building the recommendation system prototype as UML use case diagram, highlighting the main actors in the process of working with the recommendation system. For experts, it's possible to create a user profile based on which initial recommendations are provided. This profile forms a request for selecting resources and educational content, taking into account the type and rating for each criterion and receiving a list of recommended alternatives. Additionally, the expert can modify the parameters of their profile, thus managing their account. The administrator is responsible for configuring the prototype of the recommendation system, managing users and receiving analytical data on user interaction with the system. The set of use cases includes account management, management of selection criteria, management of electronic learning resources and educational content, generation of analytics of selection of electronic learning resources and educational content. The sphere of application of the recommendation system is, of course, educational process. The prototype of the recommendation system is developed based on three-tier architecture, and you can see it on the figure. This allowed for dividing the system into interconnected parts, distributing them functions among them, and separating the user interface from the data. The three-tier architecture includes presentation layer, application layer, and data management layers, and each of them includes all its items. The subsystem for determining the type of electronic educational resources and educational content allows the user to specify the type and select criteria that educational resources should meet. The subsystem includes a model of scene type assignment results, a database of types of educational resources, and database of educational content criteria. The system provides data visualization by creating a radar chart for each resource, where each segment represents the value of criterion based on its importance. This allows users to assess which specific aspects each recommended resource corresponds to and make a more informed choice. The functional purpose of the recommendation system in the context of evaluating educational content is to ensure objective assessment of developed methodological materials. This system facilitates convenient and efficient interaction between experts who have their own views on content evaluation and the look kit that helps objectively consider multi-phase criteria. By utilizing the evaluation scores based on established criteria and activating computations, the prototype recommendation system assists experts in conducting responsible and well-founded assessment of educational content. The recommendation system contains a database where many resources and associated information are stored facilitating efficient selection and quick access to recommended ranking. Visualization of the results through radar chart promotes understanding and comparison of content considering its characteristics. Thank you for your attention.
Thank you. And maybe somebody will have a question to reporters.
May I ask a question?
Please, Alexey.
Alexey, it is not very clear which is the role of your recommendation system. The fact is that there are some professionals who deliver their courses and they are accountable for filling educational materials and for their quality. And there is a simple feedback from students, and students answer the questions whether they like these materials or not, or whether they were effective or not. And what should the planned recommendation system add to this schema? Did you make any experiments which showed some advantage and additional value of the recommendation system?
Okay, thank you for your question. Yeah, we have used fuzzy logic for this system. What else? Valentyna.
But did you make some experiments how these recommendations were actually used to improve recommendations made by human experts due to the teachers?
Yeah, Valentyna Yunchyk has some experience. She have some scientific research on it, but for me it's the first time in this research. So maybe Valentyna Yunchyk have more explanations. Experience showed about.
Okay, maybe it will be
Thank you.
some lunch time because we have.
Okay. Okay, thank you.
Thank you
for your
report.
time and your questions.
Of course, we have questions, but cannot ask directly now. Thank you. If nobody argue, I will ask next reporter. Report number 9. Oksana Markova, Muzyka, Kuznetsov, Kumchenko, Senko. Who will be reporter? Our present report. Enhancing IoT and cyber physical system in Industry 4.0 through on-premise large language models with real-time data processing and so on. If not present, I must show their video. Video number 6. One moment. Authors not present here. One moment. Moment, I must prepare this report and share my screen. Please.
Today, for your attention, I propose to provide some information about our research. and this research is related to cyber physical systems in Industry 4.0 and integration LLM to some factories, and especially for on-premise systems, because, for example, we know about ChatGPT 4, yes, and we know also about BERT. At the moment it's Gemini from Google, and yes, this LLMs is very good and nice, but this LLMs has a very big problem is these LLMs are cloud LLMs, yes, and probably many of factories, many of industrial businesses don't want to work with these cloud solutions, and very important at the moment provide these LLMs for on-premise systems, for systems that do not have any interruptions with internet, with outside world, and these LLM systems just only inside of some factories, inside of some servers, and so on. So let's see what we have. So basically the main big part of current modern IT world is Industry 4.0, yes, and at the moment the most popular way is integration any large language models to these fields, and Industry 4.0 includes a lot of different fields, something like Internet of Things, cyber physical systems, simulation and modeling, blockchain, etc. And the main key elements for this Industry 4.0 is LLMs. And in our research we do not include GPT, BERT, and maybe some another LLMs, cloud LLMs, I mean, to on-premise. Yes, but yes, we made some comparison between Llama 7B and GPT, but unfortunately GPT is a cloud service from OpenAI, and as I know, GPT, I mean OpenAI, store all your data for duration 1 month. For example, you made some prompt, and this prompt will store for 1 month. So it's awful for any industrial environments, any industrial businesses, and so on. So the main objectives and scope of our research was investigate how on-premise deployment of LLMs can enhance IoT and CPS functionalities in industrial settings. Next, to develop a conceptual model for LLMs that supports real-time data processing. I mean, do not create a new LLMs. Yes, we want to use some existing LLMs, but we will use these LLMs for our on-premise solution. For example, we can go to the Hugging Face site, and this Hugging Face site, it's at the moment it's a huge community that already includes a lot of different LLMs. For example, Llama from Meta, it's very incredible large language model. It's totally free. On this Hugging Face you can find a lot of models with some fine-tuned data, for example with different context windows and so on. And in our research we used a Llama 2B, Llama 2 7B. I mean with 7 billion pre-fine-tuned parameters. Okay. Next. And the scope of research was emphasize the theoretical underpinnings, the development of innovative models, and the practical implementation for industrial technologies. Yes, regarding to practical implementation, it's on the some stage. We still continue to investigate in this field because this field is very modern and with very high growing. So each week we we have some new differences that we had previous week. So, but I hope in the nearest future we will get some good solution for some good universal solution for any on-premise factory, for example. Next, what we have regarding to LLMs. So firstly, it's a data processing. Yes. Next, decision making. Next, human-machine interaction. It's a top 3 very important elements for any LLMs. And so let's go through to the next slide. And yes, we investigate. While we investigate in this theme, we will we had some we defined some gaps for existing solutions, and the main gaps are comprehensive integration strategies for deploying LLMs on-premise in industrial environments, scalability and resource management challenges in adapting LLMs for industrial use, and limited research on real-time data processing capabilities and customized industrial applications. And also future opportunities is addressing these gaps could lead to more sophisticated, efficient and secure industrial operations. Potential for industry-specific customization to enhance relevance and operational efficiency. And here's our main conceptual logical schema for our integration. So it's a common schema, and regarding to this schema, what we used, what we want to use, yes, and what we suggest to use. Firstly, it is a Llama 7B. I mean second type of Llama, second generation of Llama, Llama 2 7B. Also you can use and 70B, 13B parameters, but for these cases we should use more better servers with more better CPUs and GPUs, because as many you have these parameters, as much more better hardware you should to have, because it's a performance. Yes. Next, when you create some on-premise solution, you also should have some on-premise vector database. For these moments, the best case is to use a Qdrant. Qdrant is a very popular vector database. It has ability to create. Local version of this database, and also Qdrant provide ability to use their own cloud services. So it's, I think, regarding to vector database, Qdrant is the best solution. Next, length chain. our server side, our backend was created with Python, and regarding to this, the most common and useful library is a LangChain, because LangChain provide to us ability to use a lot of tailored functions and functionality regarding to these LLMs and different IoT elements and so on. So it's a good library, middleware, and so on. Also, for creation some embeddings regarding to your information, you should have something like a Cohere. But Cohere is a cloud service, and we can't to use this inside of our on-premise solution, and that's why we also choose a LangChain.
Sorry, but I should stop this presentation and stop sharing it because authors are not present here. Yes. We have not possibility to ask questions to reporters. And therefore we should go to next reporter. And in future ask preparing their presentation, video presentation in time, 10 minutes for presentation, 5 minutes for questions. Okay, please, next report number 10, Tetiana Hovorushchenko, Yelyzaveta Hnatchuk, Houda El Bouhissi. Please, who will be reporter?
Yes, I am reporter.
Please share screen.
Do you see my screen?
Yes, yes. Okay.
Okay. Dear colleagues, let me present our research, evolution of the quality and usefulness of information technologies for supporting medical decision-making based on civil law. Information technologies significantly improve the function of the healthcare system by introducing organizational change, making it more accessible to the public and ensuring greater transparency in the activities of medical institutions. They help to improve the efficiency and quality of healthcare services, reduce the cost of providing them, reduce the time required for examination and treatment of patients, optimize the use of medical staff time, and provide consulting support to doctors. In addition, they facilitate the integration of the country's healthcare system into the global medical information space, allowing doctors to communicate effectively, assess medical archives and libraries, and interact with various medical equipment. Currently, decision-making process in the medical fields are characterized as time-consuming, complex, non-transparent, and ambiguous for both patients and many doctors. Medical practice is characterized by a shortage of time, rapid disease dynamics, and a high cost of medical errors. The introduction of information technology can help reduce the number of medical errors, provide more reliable solutions, and reduce healthcare costs. The development of cross-disciplinary information technologies is currently an important, relevant, but complex and time-consuming problem. Since, on the one hand, such technology ensures that the norms of current legislation are taken into account when making medical decisions, the correctness of the medical procedures from a legal point of view, protects the doctor and the patient from legal conflicts, and one of the hand requires taking into account the standards and principles of development of information technologies along with regulatory documents in the field of medical law. To solve this problem, the authors paid considerable attention and developed theoretical and applied principles of information technology for medical decision-making support based on civil law, and implemented this information technology for medical decision-making support based on civil law. The analysis of the subject area carried out showed the problem of medical decision-making based on civil law, which in general is an optimization problem. can be considered as a problem of binary classification regarding the possibility or impossibility of providing a certain medical service. Based on this, the considered problem is to synthesize appropriate methods of binary classification A to solve the task of medical decision support and analyze the obtained binary classifier solution, which is the purpose of our study. By synthesis for the considered problem, we mean the combination of abstracted aspects of the problem and their reflection as a concert integrity. That is, in previous works, an abstract model for supporting medical decision-making based on civil law is proposed. The final result of this synthesis is the information technology for supporting medical decision-making based on civil law developed in previous works. By analysis for the considered problem, we mean obtain an optimal solution as a result of the classification task about impossibility class 0 or possibility class 1 of providing a certain medical service based on the available civil law grounds. Thus, for the problem being solved, the abstract model can be represented as follows. On the first slide. The classification task is as follows for a sample X is real patient data or in real contracts for the providing those medical service, and no binary answers why there is a method A that approximated Y on the entire set of object X. Synthesis and analysis of information technology for supporting medical decision-making based on civil law are presented on fifth slide. To analyze the obtained solutions of the binary classifier, it will be important to measure the quality of each information technology. In essence, the quality of the binary classifier A. The quality assessment will answer the question of how well the classifier A separates classes in a given sample. Let's analyze the known statistical matrix for evaluation the quality of classifier in terms of the application to the considered problem. As a rule, the results of solving a binary classification problem are denoted as positive and negative. As a result of binary classification, all sample objects are divided into 4 types, forming a confusion matrix. Using the confusion matrix, let's consider several quality metrics of the binary classification model, which are not mutually exclusive, complement each other, and can be used simultaneously. Accuracy metric, precision metric, recall metric, F1 metric, specificity metric, TPR metric, FPR metric, and AUC metric. Methods for determining the quality and usefulness of information technology for supporting medical decision-making based on civil law consist of the following steps, which are presented on 8 to 10 slides. First step, description of each data set used for experimental studies of the quality of the proposed binary classifier A. Second, filling the confusion matrix with data to support decision-making on the possibility of a particular medical service based on the civil law. So, determination of the accuracy metric, determination of precision metric, determination of the recall metric, determination of the F1 metric, determination of the specificity metric, determination of the AUC metric. Ninth step is forming a conclusion about the quality of binary classifier A based on the values of the matrix. 10th, analysis of reasons for misclassification, why the classifier recommended the conclusion that the service is possible when this medical service is impossible. Determining of the usefulness of the proposed binary classifier. The proposed methods for determining the quality and usefulness of information technology for supporting medical decision-making based on civil law provides a conclusion about the quality and usefulness of this information technology in terms of classifying decision into possible and impossible decisions. First, in accordance with step 1 and 2 of the method for determining the quality and usefulness of information technologies for supporting medical decision-making based on civil law, let's consider the data sets used to assess the quality of each information technology as well as resulting conclusion matrix. They evaluate the quality information technology for supporting decision-making of the possibility of using reproductive technology based on civil law. We use data sets marked by experts in the field of medical law on surrogacy collected in reproductive clinics in Khmelnytsky and Lviv for the period from February 2021 to November 2023, and on in vitro fertilization collected in reproductive clinics in Khmelnytsky and Lviv for the period from November 29 to October 2022. To evaluate the quality of information technology for supporting decision-making with the possibility of donation and transplantation based on the civil law, we use data sets marked by experts in the field of medical law on donation and transplantation in Ukraine, collected mainly from the United Network for Organs Sharing database for the period from October 2020 to October 2023. To evaluate the quality of information technology for supporting decision-making on the possibility of providing medical services, therapeutic services, dental services based on civil law, we use data sets marked by experts in the field of medical on general medical services collected in outpatient clinics of family medicine of Khmelnytsky region for the period from January 2022 to January 2023, on therapeutic services collected in outpatient clinics of family medicine of Khmelnytsky region for the period from January 2022 to January 2023, on dental services collected in dental clinics of Khmelnytsky region for the period from June 2024 to February 2023. To evaluate the quality of information technology for supporting decision-making on the need and possibility of vaccination against COVID-19 based on civil law, we use data sets marked by experts in the field of medical law on COVID-19 vaccination collected in family medicine outpatient clinics on Khmelnytsky region for the period from June 2021 to February 2022. As a result of the use of information technology for supporting decision-making on the possibility of using reproductive technologies based on the civil law are presented on 13 slides. As a result of the use of information technology for supporting decision-making on the possibility of donation and transplantation based on civil law is presented on 14 slides. And a result of use of information technology for supporting decision-making on the need and possibility of vaccination against COVID, and result of providing medical services, therapeutic services, dental services are presented slide 15 and 16. Results of the study of the quality of binary classifier information technology for supporting the decision-making of various medical decisions based on civil law are presented on 17 slides. The ROC curves with calculated AUC matrix plotted for 8 binary classifier are shown in figures 1 to 8 are presented next slides. In accordance with step 9 of the method for determining the quality and usefulness of information technology for supporting medical decision-making based on civil law, we conclude on the quality of binary classifier. All the calculated values of the matrix presented in table 1 indicate the quality of all the developed binary classifiers information technologies for supporting medical decision-making based on civil law. To determine the usefulness of the proposed information technology for supporting decision-making on the possibility of using reproductive technology for the productive medicine clinics, let's consider the case analyzed by information technology. The results are presented on 21st slide. Next results are presented on 2020 slides. Conclusions are presented on 23 slides. Thank you for attention.
Thank you. Please, questions from participants. If no questions, I have one. What kind of data about civil law is taken into account for decision making? how represented civil law in your system, information system?
We used data about patient, for example, diagnosis, results of.
But I'm about law, about законодавство, civil law. It should be, for decision making into account. You have some formal representation of civil law. It's a problem.
We used civil law medical contracts for medical contracts for use different medical procedures.
Yeah, but the contracts, Word document, some PDF document, and
as PDF documents or Word documents.
Yeah, but somebody should consider correspondence between such document and content of such document with decision taken in each case. For example, you mentioned experts, by the way, but without experts, such system will not work, because somebody should consider, is it according to such contract or document in this field, or not in accordance with contract, and without some inserted expert in this system will not work.
At the first, we used expert knowledge for the medical contracts. After that, when we have constant form of medical contracts, our system can be work without experts.
Mm-hmm. Okay. Maybe other questions? No? Then thank you for your report. Thank you.
Thank you for attention.
Yeah, and we are going to next report. I see Alina Yanko, maybe it's your next.
Yes, it's
report.
mine next. Mine. You're right.
Please, you have
I can start,
possibility
yeah?
to share your screen and
Okay.
present.
Can you tell me?
Yes, we see your report.
Only I will ask, it will change in the full screen or no? 1 second.
Yeah, very good.
It change?
Full
Now
screen. We have seen second page.
Now the problem of formulation or no?
Problem of formulation, yes.
Okay, perfect. Because sometimes in the full screen it's not changing.
Mm-hmm.
I will start. Dear colleague, I'm Alina Yanko. To your attention is offered report on the topic methods for a detection of the modified DDoS cyber attack on the web resource of an information and telecommunication network based on the use of intelligent systems. The authors of this paper are presented on the slide. Web services hosted in information and telecommunication networks require reliable protection against cyber attacks. Most modern information services are characterized by increasing requirements to ensure availability. One of the negative types of the cyber influence in info telecommunication networks is denial of service attacks, and existing approaches for detecting attacks of this class are primarily based on the classical signature analysis and may also be based on the use of artificial intelligence at the current state of information technology development. However, existing approaches to implementing detection system don't take into account the potential modification of cyber attacks, which makes their detection challenging. Therefore, it is proposed to use intelligent system to improve the recognition of the modified cyber impacts aims at the denial of service of web service in information telecommunication network. General fuzzy inference system structure is represented on the figure 1. This system should be configured based on information about the level of traffic anomalies and data of the individual behavioral characteristic of the web resource. It is proposed to improve the approaches to detection of denial of service attacks by implementing several stages of implying fuzzy inference systems. At the first stage, it is proposed to use an adaptive fuzzy neural system to determine the level of traffic anomalies. See figure 2. At the next stage, it is proposed to carry out the measures to classify attacks based on signature and intelligent analysis methods, taking into account the behavioral characteristic on the host.
Right.
And fifth structure used to determine the level of traffic anomaly is represented on the figure 3. It is proposed to use the following input values: number of the income packets during the observation interval, number of outgoing packets during the observation intervals, and rate of change moving average of total packet number during the specified observation period. And fifth structure for determining the presence of DDoS attack of web resource is present on the figure 4. The number of the input values is 3. K, which represents the traffic anomaly coefficient, X1, which represents the host load level during the current time interval, and X2, which represents the rate of change of average moving level of the host load during the specific observation period. The result of fuzzy inference based on the use of this and this is finding a functional dependence to determine the presence of a modified attack. The training metric, which was formed for this purpose, shown on this slide, and the result of ANFIS training is adjustment of weights of the first and fourth layers neurons. The shown ANFIS structure involves 5 layers. Each of the present layers is required for the fuzzy inference procedure to find an indicator on the presence of the modified DDoS attack. Expressions for each present layers are shown on this slide. The methods for detecting modified cyber attacks involve the following steps. First, accumulate and structure statistical data on basic traffic characteristic in a defined segment of info telecommunication network. Second, synthesize the ANFIS architecture and its implementation of info telecommunication network web sources to determine the level of traffic anomaly. Third, set up the ANFIS parameters by training based on the traffical telemetry statistic in info telecommunication network, which has been collected over previous time intervals for specified anomaly levels. Next, determine the level of traffic anomaly in info telecommunication network segment using ANFIS. After, check the main characteristic of traffic with a signature database, accumulate and structure data on the behavioral characteristic of the host of which the web resource is located, synthesize ANFIS to detect modified DDoS attack, taking into account traffic abnormalities and behavioral characteristic of the web resource, and conduct fuzzy inference based on the ANFIS to detect a modified DDoS attack, and in the end, take a decision to the present of DDoS attack for web resource. and conclusion. The main stages of the method for solving problem of a modified DDoS attack detection in info telecommunication network are considered. It is shown that in addition to traffical telemetry data, it is necessary to take into account the behavioral characteristic of the host of which the web resource is deployed. Therefore, a feature of the synthesized neural phase attack detection system is the consideration and using the traffical abnormality coefficient, the level of host load, and the rate of change moving average for this value input variables. And this allows obtaining the value of the network traffic anomaly indicators, which provides a multi-stage attack detection procedure. We synthesize and fuse to detect modified DDoS attack, and algorithm for training this system on the test data was selected, and its effectiveness was investigated, and the proposed methods for the detecting of modified DDoS attack will allow security administrators to receive early warning information about modified attack threats in order to take the necessary measures to ensure the availability of web resources. Further research should focus on generating statistics of effectively train the neural phase system and conducting research with a different set of input parameters to determine modified DDoS attack in various segments in info telecommunication network. Thank you for your attention.
Thank you very much. And interesting and important task. Any questions from the participants?
May I ask a question?
Please.
Please, where did you take data for data sets from? I mean that for training any neural networks, you should have a history of real DDoS attacks, and to train these models on this history. Did you have such a history for forming such a data set?
Yes, sure. When we was research this topic, we take to account the history of DDoS cyber attacks from some local area network of one company, its financial structure of Ukraine, which was have special kind of modified DDoS attack on this company, and we use it and modulate in MATLAB.
Thank you. And another question. Now it is proliferated to use methods such as naive Bayes classifier to classify different kinds of attacks. Did you think about this direction?
For sure, we think about this because if I hope this method will be used in a security system, some like big company or something, for sure we think about this, but this issue wasn't considered in the framework of this research, but we will work on this direction for sure. Thank you. Really good question. We think about this even we speak with authors that we should, next step of this research should be this step.
Thanks.
Thank you. Other questions?
Thank you.
No questions. Thank you very much for your report.
You.
Yeah. We are going to next reporter. Victoria Vysotska is present. Victoria Vysotska. Computer linguistic system architecture for Ukrainian language content processing based on machine learning. I'm afraid is not present. And we have not pre-recorded video with such presentation, therefore we try to change the order of our reports. Yeah, and next, Oleg Veres, Pavlo Ilchuk, Olga Kots, information system for real estate trading operations based on data analysis. Please.
Hello, everybody. Yes, one minute. I will share my screen. Okay. 1 minute.
We see.
Yes, okay, super. So let's start. Today our topic is about information system for a real estate trading operation based on data analysis. So we continue our previous research. So maybe some of you already have heard a part of it on previous conferences. So I will try to give some new information than previous. Real estate transactions involve significant amount of money, and everybody understand it. And we don't realize such operations day by day. We do it really seldom in our life. But at this moment, of course, we need the correct evaluation of real estate because it plays a main role in the trading process. And traditionally, of course, we analyze the value of our real estate based on some data sets, and to add more features, more new possibilities to evaluate it, it's necessary to improve systems, how to do it, especially for that participants which do it more often than at once in their life. The implementation of newest IT technologies helps us to do it more correct and in real time. So nowadays it's often used implementation of artificial intelligence. Of course, we try to add traditional methods with newest technologies to involve possibilities to work in real time, not to base our decisions just on previous data. Also, we can highlight advantages of using such newest technology like artificial intelligence. It's time efficiency, cost reduction, integration of geodata, clear understanding, enhanced investment decisions, enhanced precisions, and so on and so on. The most popular applications we analyzed in our research, and we tried to compare them. So you can see on the slide features used in comparative analysis. In our article, you can find the big table with these results. And have to add that the most popular in Ukraine, it's OLX and in Maria. Of course, there are also other possibilities to work with real estate, but it's the most popular. The to-be business process diagram is presented here. It includes the use of the information system, shows that the decision-making process for purchasing real estate has been greatly simplified and involves far fewer steps. And after filtering the property by the specific parameters, the buyer can choose the option he is interested in. And it's really important because each of us has different priorities when we make our choice with real estate too. For someone, the best is price. For other ones, it's a location. For third persons, it's some possibilities where to go, where to make sport or something other. Based on the program's tasks and functions, as well as the intended users and their capabilities, we constructed a use case diagram. You can see it on figure 2. Also, we have built class diagram. You can see it on figure 3. And here you can see the responsibilities and the main processes which we foresee with our information system. These slides shows you diagrams that explain how the process of buying and selling real estate works for users of this system, because we understand that different tasks of user and seller and the different algorithm how to realize the trading operation from their point of view. Of course, we foresee that the process of creating a machine learning model is conditionally divided in 4 stages. So we understand the first stage, we have to accumulate data, we have to filter data, check them, add some missing data according to that approach which is suitable for us. Unify data, determine the coordinates of real estate, supplement of geographic data of the property, and so on. Second stage involves identifying the minimal set of crucial features and parameters of real estate that significantly impact machine learning models' ability to forecast real estate value. Third stage, we work with our data. We divide them for training and testing data. We try to form the model which will be possible to use in the future. And second stage, we evaluate our model and try to make conclusions, is it good or not. So we realized all these 4 stages and the model was built, which can be used for this. How it will be realized? To facilitate the implementation of this system, a microservice architecture was chosen for its ability to provide simplicity, flexibility, and scalability of the process. And here you can see scheme of operation of the data providing service. On next slide, you can see the parts of back-end service and front-end service. Of course, we can join them together and build the common model. And different possibilities will be used to realize it in real life. To develop back-end service, we will use mainly Java programming language. To work with front-end service, we will try at maximum level visualize our data, present information in a user-friendly manner, because it's the main necessity of this part of the system. To test our model, we used data formed by our hands, yes, and we analyzed it and show that the best results you will receive using random forest regression as the basic of this model. Also, in the figure 11, a red point shows the predicted by the model values, and the blue ones shows the real values. You can see that they are really close to each other. It's a good result for us. And figure 12 illustrates the percentage of absolute error in forecasting real estate value. The average error stands at 8.49% with a mediation 1.9. So in general, we can say that our model performed well, and our results can be used in real life in practical way. Here you can see some results, yes, how the system will work. So figure 13 depicts the interconnected containers of all individual services utilized in the system via Docker Compose. The servers launched successfully, affirming the accuracy of the configuration. Figure 14 and 15 are shown as the results of the system, which we can see how the visualization works and so on. So the systems work in general. And to conclude this, I have to say that we examined both Ukrainian and international applications, found the advantages and disadvantages to use them in our model. We developed an information system building the training model and got the real good results. We divided our model development for 4 stages, and the development information system will streamline and expedite the process of discovering optimal real estate of purchasings, as well as facilitating its assessment for future sale. We hope that it will be useful for buyers and for sellers, for investors, for other agents involved in business processes, because nowadays it's necessary to make decisions fast based on real data, not on the old data. So expecting that model will work in real life. That's all about our research. If you would like to read more, please read it in full version and write to us about questions. Thank you.
Thank you. Please, questions from the participants. Your model is placed somewhere to access, to test, or some version, free version exists or not?
No, still not just testing version made in our close company, not presented for the society, but we hope that after some improvements, it will be possible to present it for free use, maybe for charge use. Of course, it would be good to earn on this, but free use as the beginning would be really good.
As I know, such real estate market very fast changing. And
nowadays, yes, because yes, we understand that it's changing fast because economic situation is changing fast, and our models foresee that we must work with real data, we must accumulate data, and as actual they are, as better decisions we will get. So, of course, the real estate market is slower changing than, for example, money market or for exchange market, but it is changing nowadays, and it's necessary to build models on real data. We try to realize it, hope that it will work good. Results shows that it will. I have to implement it in real life.
Okay, thank you.
Thank you too. Nice to see you again.
Okay, we are going further, and we have one report before lunch break. Roman Peleshak, Andrei Hudei, Igor Matvey, Roman Miroshnik, Irina Baglay, Lina Галас. Хтось є? Доповідачі. Somebody maybe not understand me in Ukrainian. I can repeat in English. Anybody present from reporter number 14? Roman Peleshak, Andrei Hudei, Igor Matvey, Roman Miroshnik. Nobody? It looks like we ended with presenting.
Sorry, dear Chairman, may I start our presentation? We have our point in the program see you later. If there are time, can I start our presentation? This is numbers 19 or 68.
Which one? Your report number
Is number 19 or
19.
68? Yes.
19. I'm afraid what we will do is when your turn will come, then you report now and next.
Yes.
We shift our order. It's not good.
I know, but we have the time to before the lunch break.
Okay, and then we will have time at 17 o'clock. We will have 15-minute break when your turn will be next time.
I hope all is organized. You will have no problem with them. Okay, thank you very much. I'm sharing my presentation.
Please.
Do you see?
Yes.
Thank you. Ladies and gentlemen, let me present our presentation, the role of public network optimization in reducing carbon emission. And now the purpose of this presentation is the world important conduct at the study the analysis of passenger transport in cities to identify existing problem and produce it that prevents the introduction of the consent of smart city into the city transport is general. And passenger transport is a participant to create an attractive during the cities, reduce the carbon footprint in public transport and contribute to the sustainable development of city to implement the concept principle of the smart city. Now we use a dataset. Our dataset contains the following data: transportation of passenger by transport, total number of bus routes, the total number of us at the average age of a vehicle carrying on urban passenger transportation, and the number of bus transport stop, transportation of passenger, the same in train and travels. The histogram displays that the volume of passenger transportation by public transport has a downward trend. A similar downward trend is observed when studying the dynamic of passenger transportation by bus public transport, tram transport, and trolleybus transport. Result of the dynamic of passenger traffic in the public transport, bus transport, and electric transport in Lviv until to 2025 is shown in this figure. The high determination indicated in the range before the 0.83, 0.88, and for passenger transportation, this public transport, bus transport, trolleybus, bus, and tram, respectively, have different polynomial function presented on this slide. They are presented, and you can see this result. And analyzing the existing distancing on emission of the pollution into the air from the mobility source in the Lviv region is follow. We can see that the guarantee restriction into 2020 increase the tendency to the decrease, yes. And as this slide presents the analyzing of carbon dioxide emission by mobile source of the Lviv region. Regarding the dynamic of the carbon dioxide emission by mobile source in the Lviv region, I have two different trends into two period ones from 2006 to 2016 and other from 2016 to 21. Caused by the changing in calculation methods, such since the emission from road, railway stand, evaluation, and water transport, to which since 2007 emission from production equipment mobile have been added. And since 2016, the methodology takes into account data in the final use in the fuel by the bus transport, which are obtained from the Ukrainian data information. And as a result, For optimization, the public transport network within the concept of smart city in its approach, we recommend some direction. Among the known direction of the optimizing public transport network within the concept in smart city, we will single out three main approach, given probability of public transports, and the last is transition on electric and hybrid vehicles, implementation of monitor information technology. As a result, we analyze existing methods and means designed to optimize the functional of passenger transport system in smart city from the point of view of the reducing carbon emission. They include the following: intelligent transport system, electric vehicles, transport sharing networks, smart application information, innovating payment system, unmanned vehicle, information board and announcement system, network of bicycle paths and equipment site, and environmental monitor system. All have this some sub approach. Okay. Now there are the diagram of the intelligent route optimization system. There are an activity diagram, a state diagram, and the deployment diagram of optimization network of transport system and passenger transportation. This is shown on this slide. As conclusion, during the analysis of passenger transportation in the region city within the population of less than 1 million registered resident and development public transport network. As a result of the analysis and classification of this conceptual approach to the optimization of the organization of public transport network to reduce carbon emission, there are three main approaches. They are established: prioritization of public transport, hybridization, electrification of vehicles, and the implementation of IT monitors. Thank you for your attention. I hope I am in time.
Thank you.
Thank you very much for your convenience. Thank you.
And questions? No questions? Thank you.
Thank
Again,
you very much.
we are going by now our scheduler. Ask again, Victoria Висоцька, Роман Пелещак, Худий, Матвій, Мірошник, Баглай, Lisa Галас. Nobody? No. Then please let me claim lunch break up to it's 15 by Central European Summer Time, or 14 in Kyiv time. 14 o'clock, meet you again. Please welcome and break for this moment.